Okay, on quadratic word problem, on any word problems actually, but on quadratic word problems, if it references a description of something that can be drawn, draw it. Okay? Read this problem. This is the first problem at the top of your page. Read the problem and just ask yourself, if you know what they're talking about, you know where everything should go just based on reading the problem. Plot of land for sale has a width of X feet and a length that is 8 feet less than its width. Farmer will only purchase the land if it measures 240 square feet. What value of X will cause the farmer to purchase the land? Now, just reading that, you know where stuff goes. Yeah, some of you might. So, what shape is this land? It's going to be a rectangle, probably. What's the width? X. Let me ask you this. Does it matter which one I say is the width and which one's the length? No, it does not matter. It does not matter. So that's X. What's the length? 8 feet less. What does that look like? Minus 8, okay. And then it says that it will only be purchased if it measures 240 square feet. Square feet, what did they do to find that? How do you find square feet? They didn't square both of them. It's area. Length times width. It's area. So the farmer will only buy this.
If X squared.
No. If the length times the width equals 240. Right? Length times width. 240. Alright, next question. With it looking like this, is it ready to solve? No. Well, it looks like it's factored. Right? I mean, X times, that looks factored to me. What does it always have to equal before we start solving it? 0. It has to equal 0. So what we're going to do is we're going to say X squared minus 8X minus 240 equals 0. Does everyone know how we got from here to here?
Yes.
Okay. Can you factor this? Yeah? Can we think of two numbers that multiply to equal a negative 240 and add to equal a negative 8? What? 12 and 20. 12. One of them has to be negative. Which one? Negative 20. Okay, so I'm going to say X squared minus 20X plus 12X minus 240 equals 0. Minus 20. So X minus 20 times X plus 12 equals 0. Minus 20 equals 0. X plus 12 equals 0. Either X equals 20 or X equals negative 12. Can X be negative 12 in this problem? Why not? I worked it out. That's right. Yeah, can you have negative 12 feet? No. So, 20 feet, X feet, 20 feet is the value of X that will cause this farmer to buy this land. That's what we're looking at right there. Actually, this room is bigger than that piece of land. That's right. you read this one. Try to draw the picture for this one. Try to set this one up. I'll give you about a minute, and then I'll jump in. All right, what does your picture look like? Okay, that's a good start. What do we know about this rectangle? Okay, the length is 5 inches more than twice the number, so I'm going to put 2x plus 5, because that's 5 inches more than twice. And the width is 4 inches less than the same number. Just x minus 4. Because the number we don't know is x. And it's 4 inches less than that. So x minus 4. What else do I know? The area is 15. How do you find area? Length times width. And those equal 15. So I have 2x squared minus 8x plus 5x minus 20 equals 15. 2x squared minus 3x minus 35 equals 0. You have to do what? Can you factor that? Can you take two numbers that multiply to equal a negative 70 and add to equal a negative 3? 7 and 10. Which one needs to be positive? Which one needs to be negative? Take out an x, I have 2x plus 7. I take out a negative 5, I have 2x plus 7. X minus 5 times 2x plus 7 equals 0. That means x minus 5 equals 0, or 2x plus 7 equals 0. Either x is 5 or x is a negative 7 halves. Which one is it? X is 5. Can't be the negative 7 halves. Now I will say, if it was just this one, it could be a negative 7 halves. But that's still going to give me a positive number when I put x in right there. But that one messes it up. You go back and check it. You can't use that. It can be. And that's what I'm saying. If your two problems were, let's say they were x plus 10 and x plus 15, and you found out that x was negative 3. Well, that would work because you still come out with positive each time. But if it was like negative 20, that wouldn't work because that makes you come out with a negative. So, it just depends.
Just remember, you can't have a negative one.
70? 270. 2 times negative 35. Got it? You ready for the next one? If the measure of one side of a square is increased by 2 centimeters, and the measure of the adjacent side is decreased by 2 centimeters, the area of the resulting rectangle is 32 square centimeters. Find the measure of one side of the square, the original figure. Okay, so let's draw this. So we had a square, right? But for one side, and it was x, by x. But one side we added 2 centimeters. So now this side is x plus 2, right? And the other one we took away 2 centimeters. around, that's x minus 2. Come out with something like that. Okay. And what's the area of the new part? 32. So that means x plus 2 times x minus 2 has to equal 32. Alright. So I end up with x squared minus 4 equals 32. Or x squared minus 36 equals 0. That one's pretty easy to solve. You can solve that one using square roots. You don't even need any of my fancy math. Yeah. X squared is 36. Can it be the negative? No, we're just looking for a principal square root here. X is 6 centimeters. Yeah. Alright. Please come in next. Yes. Among all rectangles that have a perimeter of 20 feet, find the dimensions of the one with the largest area. Alright, let's talk about this. We know the perimeter is 20 feet, right? How do you find perimeter? Add all the sides. So 2 times the length plus 2 times the width is going to be 20. Yes? Yeah? Okay. I can't work with like 2 lengths. I can't work with length and width. I have to have one or the other. Right? Okay. So you want to work with L's or you want to work with W's? W's? Okay. So I need to say that the width is 10 minus L. So I'm looking for a maximum area that right there. The length times the width. Because you said you wanted to work with that W, so we did that. Does everyone see how we got from here to here? Yes? No? No? Okay. They gave me the perimeter, right? And you told me that perimeter was 2 times the length plus 2 times the width. So 2 times the length plus 2 times the width is 20. Then we decided to solve for W. Because we can't work with 2 different variables. Not with just one equation. We need one variable. So we rewrote this in terms of length. The length times the width gives us the area, right? The length times the width gives us the area, right? Now, this is a little bit different of a question. Do we want the 0? Do we want the area to be 0? What are we looking for? The largest area, the maximum area. What point? That point has a name on a quadratic. What's the name of that point? Yes, but it has another name. It's a quadratic that opens upside down. That point right there, that's your maximum. What's that called? Remember the name of it?
Nope. I'm looking straight up.
Are you ever anything else?
What does it start with? What does it start with?
Vertex.
Vertex. Yeah, you're looking for the vertex. This is a question about a vertex. This is a question about zeros. I gotta mix it up on you. So, easiest way to solve this one, get your calculator out. I'm going to show you a wonderful trick on your calculator.
Mine can't see the graph in the graph.
Alright, go to y equals, and then y1, put in 10x minus x squared. 10x minus x squared. And x is right there next to the alpha button. Just hit that. 10x minus x squared. Now, hit graph. You have your upside down parabola there. Okay, if you can't see the top of the parabola, go to zoom, and then zoom out, which is number 3, and just do that until you can see the top point in your parabola. Zoom out, zoom out, zoom out, zoom out, zoom out. Zoom. 3.
Count for it.
There you go. Zoom, 3, enter.
Oh.
Yeah, you have to actually tell it to go ahead and zoom out. And enter. No, no, no. Don't go back in. Okay, now you have to do it again. Enter now. There you go. Alright, now, once you can see the top of your parabola, alright, go to second calc. It's stuff. Calc is spelled right.
I don't know how to play.
Alright, so you see where it says maximum. Alright, hit that button. And now it's going to ask you the left bound and the right bound. So you move your cursor until it's just to the left of that maximum and hit enter. And then it's going to say, okay, well, what's the right bound? So move it till it's just to the right of it and hit enter. And then your calculator's going to say, do you want me to guess? And you're going to go, yeah, because you're a calculator. Please, give me your guess. And what's your maximum? What's your y value? 25. Yes. Your maximum area when you have a perimeter of 20 is 5. Or is 25. 25 square feet. 25 square feet. Alright, just a little calculator right there. Now the next one, back to fences. No, I just want the maximum area. It's going to be a square. X is 5. 5, 5, 5, 5. That's 20. Alright, a farmer with 400 meters of fencing wants to enclose a rectangular plot that borders on a river. The farmer does not fence the side along the river. What's the largest area he can enclose and what will the dimensions be? Okay, I really just want us to figure out the picture on this one because you have one of these in your homework, but it tells you the area that you're shooting for. You just have to find the rest of it. But people have a lot of trouble figuring out what this fence looks like. Okay? There's a fence down by the river. Okay? Here's the river. It's rectangular. We know how much fence we have, right? How much fencing do we have? 4,000. These two are the same because it's a rectangle. So how much does this have to be? How much pence do I have? How much have I used?
1/3,
No.
2/3.
Do you know how much that is? Because if you know that that's 2/3, then we don't need to use x. You use x amount here and x amount here. 4,000 minus 2x. Right. That's how much this is. So if you were finding the area, you would have 4,000 minus 2x times x. There's your length times your width. Okay? We're not going to solve this. Let's do it next time.